okay, on the homework that I talked about yesterday, um, you're going to have to input the script into MATLAB. So the first thing is I emailed everybody a copy of the script. So if you go to the email, you're going to see, like right now you see my email, you should have gotten this script, all right? So it's all you have to do. You don't even have to type it in. I'm making this very easy for you. You just cut this, right? You copy it, right? Copy it. And then you can go to MATLAB. Now, it may come up looking different than what I have on my screen. So, but what you want to do is you want to find the command window. See here, up here it says command window, okay? So you're going to find the command window, and then you're just going to paste it in here, right? I don't know why it makes that, okay. So you're just going to paste it in here, and that's it, right? Now, you put the cursor here, right? And then you hit return. All right, so you want to hit return on this thing here. I'm going to actually show you two ways of doing this. All right, so then you hit return, and now it's going to generate the direction field. It normally happens really quick. On my computer, when I have different applications running right now. So that's it. That's a direction field, right? So I made it extremely simple. You know, you can make it bigger. You can zoom in on it. All right, let's see. Okay, so here you got these zoom buttons, right? Now what you have to do, I gave you initial conditions, right? So you have to find the initial condition. That's all you have to do. You're going to generate the direction field using MATLAB. And then you can either print it out. If you don't have a printer, take a picture with your phone. And then you're going to draw the solution of the differential equation for the initial conditions that I give you, right? So the problem has three different initial conditions, one in this region, one in this region, and one in this region. And so you got to draw, you know, you have to find the initial condition. And so it's really, you know, it's almost like kindergarten stuff, right? Things that you do in kindergarten. All right. Now, that's one way of doing it. Okay, so once again, by the way, if you want to clear the screen, you just hopefully, that's how you can clear the screen. You just type CLC and it'll clear the command window. So once again, you're just going to go to, everyone should have it, right? When you go to your email, right? So you just copy it, do it again, copy it, then you paste it. And then, okay, so that's where the cursor is. Now, I know that in the past, I've had students that know a lot about MATLAB and students that know nothing about MATLAB. And it's really nice in the classroom. Actually, MATLAB is really nice to use in the classroom where I used to team up students that actually had a course in MATLAB with students that didn't know any MATLAB at all. And it turns out MATLAB is a lot easier to teach in a classroom environment than it is online. But anyway, so that's it, and then it's going to pop up a window. So there's the solution, right? This is the graph. Okay, piece of cake. Now another way of doing it is as follows. You could hit new script, right? I could hit new script here, right? Well, first let me clear this. I should probably clear this. I was afraid of that.
Professor, I have a question about the MATLAB question.
Right. Go ahead.
Is it okay if I use an image processing software like Photoshop or Adobe Illustrator to draw vectors?
You want to use another piece of software as opposed to MATLAB to generate the vector field?
No, not the vector field, to draw the lines.
No, I want you to draw them by hand. I don't, I'm not, it's not clear to me what you're requesting.
So in Photoshop, you can draw you can draw Bezier.
Oh, I see what you're saying. Oh, yes, you can do it that way. Sure, sure. I understand now. In Photoshop. So you want to draw the line? Yeah, you can do it that way too, and then print that out. That's fine. That's fine.
Okay.
Okay. So all right. Another way of doing it now is that notice I hit script. Okay, and now it brought up an edit window. All right, just showing another way. It brought up an edit window. So now I can paste it in this edit window. All right. I don't know why it makes that. All right. So now I paste it in the edit window. Now I could save it. All right. I paste it in the edit window. I can save it. And let me call it, I'll call it exam 1, problem 6. Okay. I'll call it exam 1, problem 6. Okay. So, so now up here, you see, I know you probably can't read this, but it says exam 1, problem 6. Maybe it's a little bit difficult to read. So here's the script. Now in the command window, so this is my edit window. So now in the command window, I could type exam 1 and make sure this is case sensitive. Exam 1, problem 6. Oh, see, this would not work because I got a capital R here. Exam 1, problem 6. I typed it in, right, it's case sensitive. And then hit return, and it's going to run this script. So that's, so that's two different ways of doing it. And this is actually the better way of doing it. Put it in the, and then save it. Now, actually, if you wanted to, if you had different, like this is actually doing the slope field for an equation that's y times y minus y divided by 4, right? So if you had different equations, and this is the window. So if you had different equations, you would just change this, right? Because this is the differential equation, the slope. In this case, for this problem here, is y times y minus 4, right? And this is so this is an autonomous differential equation, and this is the window. This is defining the window. Okay. Okay. All right. So I made this real easy. So check your email and make sure you have the script, and just copy and paste it into either the command window, or you could select new script and then put it in the edit window, give it a name, save it, and give it a name. And then in the command window, you just type the name. Okay. So everyone's going to get 100 on that problem. All right. Any questions? Okay. So now it
So
takes up a lot of, yeah, someone have a question?
yeah, I was a little confused on the drawing of the line on the graph. Can you go over that again?
Yeah, well, I don't want to show you for that problem, but take a look at the video, right? We can take a quick look at that. Now I'm trying to close MATLAB. Okay, let me go to Blackboard to answer your question. Should be a little bit faster now. That was in week 1. Let's see. Okay, so you're gonna have the direction field. And what you're gonna do, so here's an example. It's actually pretty close to the problem you have. But I'm gonna give you an initial condition, and then you're gonna have to find where that initial condition is in the window and draw a line that starts at the initial condition and goes through the direction field. So you're gonna have to draw lines like this. Okay, you're gonna have to draw the lines. Okay. You can also watch a video. All right. You can also watch a video on what to do. I have a video on this. So that's all you're gonna do is just you're gonna where is y is equal to 0.1, right? So you find y is equal to 0 and x is equal to 0.1. Like in this case here, looks like that's about 0.1 for x, and y say 0. And then it's you would draw the lines through the direction field, right? So that's all you're doing. It's pretty straightforward.
Excuse me, Professor.
Yes.
So it looks pretty straightforward for R1, but what about like R2, like the very top one? Do we just start where R1
Well, I
leaves off?
give you 3 different initial conditions, so you're gonna have to draw it in 3 different places. Okay.
Okay.
Right. So in other words, like here, in this case here, it looks like, well, there is no label with the x-axis on here, but maybe y is around 4 here. Let's say x is 2, so it would look something like that.
Oh, so we'll be given an x, y. Oh, I see. Okay. All right.
You're given an initial condition, so you have to find where that initial condition is in the window and then just draw the line. It's really that simple, okay? But it's
Right,
actually pretty damn cool. That's why I want you to understand this. It's pretty damn cool that you draw the direction field and you have the initial condition, and you could estimate what the solution is going to look like, right?
Right.
That's exactly what you're doing here. You're estimating the solution is going to look exactly like this, all right? And the solution is going to look, so it's pretty cool. And so it's a concept that I want to make sure everybody understands. Okay. Now the other thing too, started from 0, you know, like you have some problems that I gave in the WebAssign where they actually start negative x, right? Like in this problem here in we have to pick the right graph. This is the right graph for this, for these critical points, right? This is the right graph for these critical points. But so you need to know that it's going down, and then here it's going up, right? From this here. And here it's going up. Okay, so think about that. Okay, so now, all right, so now I got to change. Okay. All right, this may take me a couple of minutes, unfortunately. All right, so let's see. One of the disadvantages of remote. But I think, correct me if I'm wrong, I think it's better that, you know, that you see me work stuff out as opposed to just reading from PowerPoint charts.
Yeah, it's a lot better.
All right, so it's looking a little bit better here. All right, I don't want to waste. I normally try to get it better, but let's go ahead with this. All right, so this is actually a problem I went over the last time, where we had this this differential equation, right? And this is now, we have a tank here where we got initially 50 gallons are in the tank, and the flow, the rate in which the flow rate that's going into the tank is 3 gallons per minute, and the flow rate going out of the tank is 3 gallons per minute. And we start out with pure water, right? And that salt is being added at 2 pounds per gallon, right? 2 pounds per gallon. So once again, in all these problems, it's the amount of salt in the tank at any time, right? The differential equation is going to be the rate in which the amount of salt is changing is equal to the rate of the salt in minus the rate of the salt out, right? So now, once again, the rate of the salt in we're told the flow rate is 3 gallons per minute, right? And that we have 2 pounds per gallon. So the rate in which the salt is going in is 6 pounds per minute, right? And just forgetting about the unit 6. And then the rate in which the salt is out is it's the amount of salt that's in there at a particular time, right? So that's A, right? The pounds that are in there divided by 50, and then 3 gallons per minute. Once again, the rate out is the same. So then we get that the salt out is equal to 3 times A divided by 50, right? So this is my differential equation. I didn't solve this differential equation. That's the differential equation that describes the amount of salt that that's in the tank, right? When we solve this differential equation, right, we end up getting some function of t at any time t. We know what the amount of salt is. Okay. Now I didn't solve this differential equation, but I want to do a problem now that's a little bit harder. All right. Why don't you try? Okay, so in this case here, before I do it, I'm going to do it. Before I do it, let's say we have a large tank that's filled with 700 gallons of pure brine, and 5 pounds of salt is pumped into the tank at a rate of 70 gallons per minute. The well mixed solution is pumped out at a rate of 14 gallons per minute. Find the amount of salt in pounds, right, at time t. So this problem is a little bit more complicated. That the rate in which water is going in is less than the rate in which water is going out. All right. So I'm going to give you a minute and see if you could come up with the differential equation. Okay. And then I'm going to do it. I'll give you a couple of minutes to try to come up with the differential equation. Right, the rate in, I'll use this, the rate in is going to be 5 pounds. Normally the rate in is pretty simple, per gallon. And you could use dimension analysis too. And then 7 gallons per minute. And so that's going to be 35 pounds per minute, right? 35 pounds per minute. Okay. You're always going to have, remember now, A is the amount of salt, and this is per unit time. So the ADT, the units have to be pounds per minute, right? So that's the rate in. Now the rate out, remember now, what we had before, the easier problem, we had the amount of salt at a given time, and that's in pounds, right? Out, whatever the amount of salt that we have in the tank, right? That's A. And then we had that previously, the reason why I did the easier problem, went over the easier problem, we had 50 gallons, right? Now here we're starting out with 700 gallons, right? We're starting out with 700 gallons. But the amount of gallons that we have in the tank is actually going to be 700 minus 7 times T. Now, why is it 7 times T? Well, if I have 14 gallons coming out, right? 14 gallons per minute coming out, and 7 gallons per minute going in, then the difference is 7. So every minute I'm going to be losing 7 gallons, right? Every minute I'll be losing 7 gallons. So the amount of salt at any time T, the amount of gallons that are in the tank is 700 minus 7T. All right. And this would be pounds. Once again, the units here are gallons, right? That's how many gallons I have in the tank. And then this would be, let's see, and then it's 14, right? It'd be 14 gallons per minute, 14 gallons per minute. So this turns out to be A, right? A is going to be 700 minus 7T, right? Times 14. And then this is pounds, and this would be minutes, right? Because the gallons here cancel. And so R out, let me know if I go off the page. R out is just going to be, I could just write it as A times, let's see. Yeah, I could make this 2, right? Make this 2 and 100 minus T, right? I simplified this. I factor 7 out of here, right? If I factor 7 out of here, then the 7, right? I hope everybody sees that. Factor 7 out of here, and then I'll have the 14 up here, so I get the 2 here. All right. So this is my in, this is my rate in, and this is my rate out. So my differential equation is 35. It's 35 minus 2A divided by 100 minus T, right? So that's the differential equation. And don't forget that at time T equals 0, let's see, what are we told to? Okay, yeah, and let's see, we're told we have pure water. Yeah, pure water. So at A is equal to 0, our initial condition is that the amount of salt at time 0, right? The amount of salt at time 0 is 0. So this is initial value problem. This is the differential equation. This is the differential equation. And this is the initial value. All right. Okay. Next step. I'm going to give you a couple of minutes now. I want you to try to solve the differential equation. All right. So I want you to solve this differential equation with this initial condition. I gave this problem on an exam previously, and the students solved the differential equation, but a lot of them, most of the students solved the differential equation correctly, but some of them forgot to put in the initial condition, right? So if we want to know the amount of salt that's in the tank at any time T, we got to find the initial condition. All right. So let me give you a couple of minutes to try to solve this differential equation with this initial condition, and then I'll do it. Let me give you a hint. This is not a separable differential equation. You have to use an integrating factor. You can't separate this. Now, the other problem, the easier one, you can separate that. But this one you can't separate. Yeah, I'll give you another minute and then I'll solve it. All right, I'm gonna go ahead and solve this. You know, my solution is on, you know, the solution to these problems are on Blackboard. But let's go ahead. So here's the differential equation that we came up with. Okay, so this is not a separable differential equation. Okay, so the first thing we have to do is we're going to solve this using an integration factor. And so the first thing I'm going to do is I'm going to put it in the right form, right? I'm going to write it like this. Plus, bring this over to here. And that's equal to 35. Right? Just brought this over to here. So now notice my P of t, right? Remember now, when we solve the differential equation, we have to get it. The first thing we need to do is get it in this form. Right? Now, in this case here, the f of x is just a constant, but this is, you know, now we're dealing with a and t. All right? So my P of t now is just going to be 2, right? Because the a is like the y, right? The a is like the y. That's my P. So now my integrating factor, which is a function of t, is going to be e, and then it's the integral, right, of 2 times 100 minus t dt, right? So let's see. So this is going to be equal to e. Now, what is this integral? This integral is going to be, let's see. This is going to be minus, right? I got this minus on here. Minus the natural log of 100 minus t. Oh, I forgot 2.
Times 2, yeah.
Yeah, that's 2. Right. Okay, good. So, right. So we see when you take the derivative of this, you get this, right? You get the 100, and then you got the minus sign here, which cancels with that minus sign. Okay. All right. So, all right. So I can write this now as e, the natural log of 100 minus t to the minus 2, right? So what is this going to be equal to? This is going to be equal to 1 over 100 minus t squared, right? So that's my integrating factor. Okay, so now I got the integrating factor. So now I'm going to multiply both sides of the equation, both sides of this equation, right? I'm going to multiply both sides of this equation by the integration factor. So let's see. So what do I get then? I get now here I'm going to have yeah. So this is going to be a cube. Right, that's cubed, right? And then this is 35. Okay. All right. So now I'm going to integrate both sides. Let me know if I go integrate this. I'm just copying it over here. This is dt. And then I integrate this side. Okay, so far so good. Okay. Now, if we did everything right, what is this integral? Well, this integral is just going to be equal to a, right, times the integration factor. So this integral, it looks complicated, right? But the way we set this up, the way, you know, I showed you why this works when we first did this. And if you understand why it works, that's fine. But the important thing is to be able to how to carry it out. So, all right. So this integral now is just a times the integration factor, which is 100 minus t squared. Okay, that's what this integral is. And if you take the derivative of this, you'll see that you'll get this back. Okay. Yeah, you'll get this back. Right, because when you take the, yeah, you'll get it back. All right. You can convince yourself of that. And then this integral here, let's see, what's that integral there? This is going to be 35. Let's see. 100 minus t plus c. Okay. Right, that's what this integral. I find it easier to figure out what do I need, what do I need if I take the derivative. When you have simple integrals, right? If you take the derivative of this, I'm going to get a square here at the bottom. Then I'm going to have a negative sign, right? And then, but then I have this negative here, all right? So that's it. Well, I'm still not done yet. I want to solve this for a. So the next step, I guess I can write this as a is equal to 35, right? 100 times t, right? Right? Yeah. Plus c, 100 minus t squared, right? Multiply both sides by 100 minus t squared, and I get this. All right. So now, let's see. So now what do I do? Well, now I know that when a is equal, when a is 0, at time t equals 0, this is going to be 0, right? So I put in my initial condition, I get 0 is equal to 3,500 plus, I remember when I did this problem once before, I forgot to square this. So it's going to be c times 1,000, 10,000, right? Yeah, forgot the square. Okay. So, all right. So now I can solve this for c, right? So let's see. I guess I could get rid of those things. I can say that 35 plus c is 100. So I'm getting that, that minus 35 divided by 100 is equal to c, right? Bring the 35 over here, divide by 100. And I can write this as minus 7 over 20, right? But divide, if I could reduce this to 7 over 20, right? 5 goes into 3570 out there, 7 over 20. All right, so that's what my value of c is. So my final answer is a is equal to 35, 100 minus t plus, no, that would be minus 7 over 20 times 100 minus t squared. Excuse me, it's not t squared, it's all the parentheses squared. So you can write it like that. I think the answer key, though, the answer key wrote it, you know, these WeberSign should accept it like this, but the answer key had this that brought that through. I think that's what the answer key had. Okay. Any questions on this problem? So this is good practice on using an integration factor to solve a differential equation that isn't separable. And So here now, so, you know, my solution's written out nice and neat. Let's see, did I get the same answer? Did I get the same answer? Hopefully I did. Yeah, okay, it's correct.
I have a question.
Sure.
Could you explain how you got 700 minus 70 in the beginning?
You mean with the differential equation?
Yeah.
Okay. I'll do the neat part, you know, where I have it nice and neat. You mean where it's the 700 minus 7t?
Yeah.
Okay. Well, what's going on here? We're starting out with 700 gallons, right? We're starting out with 700 gallons. 14 gallons are coming out of the tank and 7 gallons are coming into the tank, right? 14 gallons are coming out of the tank, 7 gallons. So what's 14 minus 7? 7, right? So 14 minus 7 is 7. So that means that at any time t, the amount of gallons that are in the tank is 700 minus 7t.
Oh, I see. Thank you.
Okay.
Mm,
700 minus 7t is the amount of gallons that are in the tank at any time t. Now, there was another part to this problem. They wanted to know how long in minutes will it take to empty the tank. Well, there's actually two ways of doing it. One way is you could just take a look at this equation here, right? 700 minus 7t. When that's equal to 0, you have nothing in the tank. So you solve this for t and you get 100, right? Another way to do it, though, is to put, which is harder, put 0, set this equal to 0 and solve for t, right? If I set this equal to 0, this would be, set this equal to 0, this is 35. Set this equal to 0 and solve this for t, you better get 100. 100 minutes for t, excuse me, not a, right? You get t is equal to 100 minutes. But it's easier just to look at this. I think it's easier just to look at this and see that, you know, solve this for, at any time t, you got 700 minus 7t gallons. Set this equal to 0 and you see that t is equal to 100. So that was another part of the problem, is how long would it take to empty the tank? Okay. All right. I want to do a problem now that could also help you out on the exam. It's an application. Let's see. So these are actually some of your WebAssign problems. Now, the problem that I just did, I want you to do, you're going to have a problem just like that with WebAssign. Your numbers may be different. You may luck out and get the same numbers I had. But I want to do this problem here. I guess I should hide the, let's say that, well, let me do this. Okay. We have, this will be practice for the exam too. Okay, so I have this differential equation. Okay, so we have that differential equation. And let's say we want to look at the case where A is equal to 1 and B is equal to 1. Okay, okay. So what I want you to do is I want you to, and you can have a problem like this on the exam. The only thing we use X and Y, I think. So this is good practice for the exam. So what I want you to do is see if you can find the critical points and draw the phase portrait diagram. Okay, I want you to find the critical points and draw the phase portrait diagram. You may need a calculator. All right, so let me give you a couple of minutes to do this. So we're drawing the phase portrait diagram. So the first thing is to find the critical point.
Professor, can you move the paper a little over to the right?
Oh, thank you. See, I have lines on my desk, and I normally try to make it more accurate, but I didn't have the time. Actually, let's see. We also want to do a is equal to 1 and b is equal to -1, but let's do this one first. Like I said, you may need a calculator. I think you're going to need a calculator. All right, let me go ahead and do this. This shouldn't take long. Okay. So we want to set this equal to 0, right? We want to set this equal to 0. So one solution is p is equal to 0. Actually, yeah, one solution is p is equal to 0, and another solution would be is not. This is just the natural log of p. Sorry about that. This is the natural log of p. This is going to be equal to 0, right? I had p here and then, okay. So so what do we get here? We get the natural log of p is equal to A over B, right? Right? If I bring this over to this side, right? Everybody see that? This is 0. So now if I take the exponential of both sides, I get the P is equal to E over A divided by B. But in this part of the problem, we want A to be equal to B. So this is just E. All right. So I have a critical point at E and I have a critical point at 0. And I have a critical point at E. Okay. Now in between here, I want to draw the phase portrait diagram. This is where I said you need a calculator. So let's see. So here in this region here, right? If this is E, right? I want to pick a point that's a little bit above E. Let's see something here. Yeah, I want to pick a point that's a little bit above E. So let's say in this region here, that's not what the curve looks like, but in this region here, I'm going to say that E plus 0.1, right? I'm plugging it into here now, right? Is equal to 1 minus the natural log of E plus 0.1, right? So that's all I'm doing here. I'm plugging E is my critical point. So now I'm looking for a point that's a little bit above E. So I'm taking E plus 0.1. And then I have to determine whether this is negative or positive. So now I don't have a calculator, so I'm gonna look at what the result is. Okay, so this turns out to be negative, right? Turns out to be negative. So this, you put this into a calculator, this is gonna be negative. Okay, now if I take a look at something here, now I want something below E. So I'm going to take E, I could do minus, right? I could do E minus 0.1. I could use anything. Natural log of E minus 0.1. And now I have to put this into a calculator. And I think that comes out to be plus. Yeah, that comes out to be plus, right? Comes out to be plus. Which tells me that the, right, when we got the negative sign, right, when we got the negative sign, we draw the arrow going down, right? And when we have the positive sign, we draw the arrow going up. So if I start out with an initial condition here, they only wanted us to really do this. If I start out with an initial condition here, right, this is going to be an asymptote. This is a critical point. So this is going to be an asymptote. So if I start out with an initial condition here, it's going to look like this. If I start out with an initial condition here, it's going to look like that. Okay. So so in this problem here, now I'm showing you the problem. So this would be the correct answer, right? This would be the correct answer. So here's our work where we draw the phase portrait diagram, right? So we take a point a little bit above E, and we take a point a little bit below E, and we substitute it into this equation here, right? We determine that this is negative and this is positive, and so this would be the correct curve. All right.
You multiplying E minus 0.1 with 1 minus ln E minus 0.1.
Right.
Where does that come from?
Comes from this equation here. Okay.
Excuse me.
I'm plugging it into here. I'm plugging my. Okay, let me do that. Okay. I have this equation here, and A was equal to 1, and B was equal to 1. So this is my equation, right? Right.
Excuse me, Professor.
Yeah. Let me just finish, and then I'll answer the question. I'll answer your question. So this is A and this is B, right? And that's 1 and 1. So now I'm just plugging in E to the plus. I'm plugging in E E plus 0.1 into here, and E plus 0.1 into here. Okay, now does somebody else have a question? My,
I was wondering why we're taking away the dp over dt and just setting it equal to 0. Why is that?
what? You mean why we're setting this equal to 0?
Yes.
Okay, that's how we find the critical points, right? The slope is 0. When the, remember from calculus 1, the slope,
Oh, I see. Okay, gotcha.
the slope is 0. And then we're finding, we know that the slope is 0 here, right? We know that the slope is 0. And actually, E would be a solution to this differential equation. We know that the slope is 0 here. And then we're finding what the slope is above and below the critical point. Now, this would also be a stable critical point, right? This would be a stable critical point. Okay. All right. Let's to make sure that we all understand how to do this, let's do the same problem again, but this time, I'm going to give you a minute now to, it's the same. You can get a different result now. Okay. Okay. But now for this problem here, the next part of this problem is that A is equal to 1, right? And B is equal to -1, right? Before we did A is equal to 1 and B was equal to 1. So now A is equal to 1 and this is, right? We find critical points just like in calculus 1, right? We find critical points by setting it equal to 0. And that's where, okay. All right. So, so try to do this problem now. Draw the phase portrait diagram. Draw the phase portrait diagram where A is equal to 1 and B is equal to -1. It's going to be a different result. I'm not going to give you too long for this because I want you to try to do something else too. Let's see. All right, let me go ahead and do this. So this time here, remember, just like before, you know, before we got E was equal to A over B, right? Right. But now A is going to be, right, we got A over B. Yeah. It's just, yeah, when we do it in terms of, you just, you know, leave it as A over B as opposed to minus and plus. So now this is going to be minus E to the -1, right? When B is equal to -1 and A is equal to 1, I'm going to get P. So my critical point, solving for P, my critical points are minus E to the -1. So now, and also 0, but they don't seem to care about 0. So now my critical point here, this point is E to the -1. All right. So now here's, let's see. So this is going to be A. This time it's plus. Okay, this is going to be A plus the natural log of P times. Right. Okay. So now I'm putting in. See, here's my equation. Right. So now I'm putting in A is equal to 1 and B is equal to -1. So that makes, so I got the minus sign here and the -1. That's going to make this a plus. All right. So now I'm going to put in a point above this. I'm going to put in E to the -1 plus 1 plus say 0.1, I'll use 0.1, times 1 plus the natural log of e to the minus 1 plus 0.1, right? I'm just putting in a point a little bit above this. And here I'm going to put in a point a little bit below. Minus. Okay. And then I'm going to put this into a calculator to see if whether this, I don't care what the number is. And what does it turn out to be? Okay. So let's pretend we have a calculator. You put this into a calculator. So this turns out to be plus, right? This turns out to be plus when we put it into a calculator, and this turns out to be minus. And so that means that when I have a plus sign, right, I draw my arrow going up. I draw my arrow going up, and here I draw the arrow going down. So, okay. So in this case here, right, in this case here, when I have e to the minus 1, here's my critical point. So I got the arrow going up, the arrow going down. So it's going to look like this. Right? It's going to look something like that. Okay, so yeah, it's going to, you really can't, so the only one that makes any sense is this one here. Right? It could look like this. You really can't, this is one thing, or it could look like that too. It's going to go down. But this is the only one, right? This is the only one where it goes up and goes down. So the correct one would be this here, right? This one here goes down, this one here goes down, this one goes up, and this one goes up, right? So this is the correct answer. Okay, you do have a problem like this on the upcoming exam. You have to do it. Excuse me, someone have a question?
Yes. I do not see how we get 0.1 in where we get 0.1 when we write the equations for the top and bottom curve.
Okay. As all as I'm doing is I'm picking any point. I don't have to use 0.1. I can use 0.2. I can use 0.5. I have to pick a point above this critical point.
Oh, oh, okay, I see. Just any
and
point
I'm only
up. All right.
I'm only interested whether it's positive or negative.
Gotcha. Okay.
Okay. You know, I could pick 0.4, 0.5. Normally pick a number that's, but you know, be careful. If you had, let's say I had a critical point of 1. Let's say, for example, I had a critical point of 2. Let's say I had a critical point of 0. And I wanted to figure out where the arrows are on each one of these, okay? I could pick 1.5 here, and here I can pick 0.5. But be careful that.
I don't think you can see, Professor.
Oh, okay. Okay, like here, if I had a critical point of 2, and here a critical point of 1, here a critical point of 0, I could pick 1.5 to see where the arrow is going here. And I could pick 0.5 to see what the arrow is going here. And here I could pick -2 to see which direction the arrow is here. All right, so you pick a point in between your critical points. All right. Okay. So I hope everybody is getting this. Like I said, you do have a problem like this on the exam. Let me see something for a second. I actually want to look at the exam for a minute. I think the problem you have on the exam is the log problem. I'll see if I could find it. So, okay. what I want, this is the last thing we're gonna do today. Is I want you to try now to solve the differential equation. And then I'll solve it. Okay, so. And once again, the solution is in my notes. Okay, so I'm gonna give you a hint though. Okay, so I want you to try to solve this differential equation and let u equal to, once you, this is a separable one, okay? It's a separable differential equation. Let u equal to, u substitution, let u equal to b minus the natural log of p. You may not see that offhand. It's actually pretty straightforward. Okay. Right, so solve this differential equation. And then I guess that's probably all we're going to get to today. I'll give you another minute. I want to make sure I finish it and have a couple of minutes for questions. All right, let me go ahead and solve this. Wonder if it's better with the slide on. I think better. Okay. So could you all right. Okay, so the first thing I'm going to write this is a separable differential equation, so I'm going to write it like this: dp. Now I'm going to print this p a minus b, the natural log of p, and I is equal to the integral of dt. Right? So everybody see that? I just brought this over here, I brought the dt up here. Okay, now if I let u equal to a minus b, the natural log of p, watch what happens. Then my du is equal to minus, right? My du is going to be equal to, the derivative of this is 0. So it's going to be minus b, 1 over p, right? dp. Okay. So, so that also means that du minus du over b is going to be equal to 1 over p dp. Right? So now I got that minus u over b is equal to 1 over p dp. And that's what I have here. I have a dp over p, right? So this is going to become the integral of I guess I could take the b out. Well, it's going to be integral of minus 1 over b, right? du, right? du over u, right? It's the integral of the, let's see, is this right? So, right, so this is, my u is equal to this, right? This is my u. And that the 1 over p dp is equal to du is equal to minus du over b. So here's my, this is replacing this minus 1 over b du is replacing the 1 over d dp, right? Okay. So now this is going to become minus now. Let me know if I go off. This is become minus 1 over b times the natural log of u, okay, plus t. No, it's equal to. Wait, sorry, this is equal to. Is equal to t plus. I'm going to call it c1. We'll see why in a second. Let me call it c1. I think that's what I did in my notes. Now, okay. Now you may want to do this. You may want to say now it doesn't with the c. It doesn't matter. Remember when we have a constant, it doesn't matter if you make it plus or minus. When you put in the initial conditions, it's all going to work out. And I think I showed you that. You know the first week with a problem. So, so I'm going to write this as the natural log of u. I'm not going off the page, right? Is equal to minus b times t. I'm going to still leave this as a plus C2. So this is like a new constant, right? Remember, differential equation, we have a constant, we can keep changing it. This will all work out. All right. So okay, so I took the minus b and multiplied both sides of the equation by minus b. So now I get the natural log of u is equal to minus b times t plus, and I could have made this a minus, it doesn't matter. But I'll keep it as a plus. Normally you're better off keeping it as a plus, rather than deal with minus signs. Okay. So now hopefully everybody can see now. So this is now, if I'll go up here, this is going to be, if I take the exponential of both sides, right? If I take the exponential of both sides, this is going to be u is equal to, I'll call this a new constant now, C3 e to the minus bt. Now, I hope everybody knows how to get from here to here at this point, right? Because, I can write this, when I take the exponential, right? I can write this as u, and I can write this as e to the minus times e to the C2. And then I can write that as e to the minus bt, and then I can call this C3. Okay. All right. So now I got u is equal to this. All right. But now remember now, u is this here, right? I want to solve, I have it in terms of u. I need to put it back in terms of p. So now I get a minus b, the natural log of p is equal to C3 e to the bt. Okay. All right. Now I want to solve this for p. What's the best way to solve this for p? I'll bring this over to this side, right? You bring this over to this side. So let's see. I can write this as b times the natural log of p is equal to, let's see, this is going to be minus here. Okay. Right. If I was to bring this over to this side, it becomes plus, right? This becomes plus. Bring this over to this side, this becomes minus. But then I want to solve this for p. So I like to have, what I'm solving for, I like to have it on the left-hand side. All right. So now what do I get? Well, this is a constant here. So now, see, now this is important here. You can write this natural log of b is equal to a over b. Now b is a constant, right? B is a constant. So I can write this as, I can divide through by b, but I'm just going to write this as 4c to the bt. So there's a problem where you can keep changing the constant. All right. See what I did here? I divided everything through by b, but b is a constant, and c is also a constant. So I could just make this a new constant. All right. So now I get the p. Take the exponential of both sides. I get p is equal to e to the ab, right? E to the ab. Let's see. And then this is going to be minus, right? C4 e to the minus bt. Okay. So far, so good. All right. So now, let's see. We're told in the problem. Where's the problem here? Probably can't read it. I got to put my glasses on. Where's the second page? This is part C. Oh, okay. So here, we're told in the problem that that when P is equal to 0, that at time, let's see, yeah, at time T equals 0, we get P0, right? That's what we're told in the problem. So we're told the initial condition. Okay, so so now I just have to put in that, okay, so now I just have to put in that P0, when T is equal to 0, we get P0. So I put in that initial condition. So this means that P0, right, is going to be equal to E to the A over B minus 4C. So now I have to solve this for C. Solve this for, you know, I kept on changing the number just to show you that I'm changing the constant. Okay. So so let's see. So now I can take the log of both sides, right? Take the log of both sides. So I get the natural log of P0 is equal to A over B minus C4, right? Okay, so now I got what C4 is. So C4 is equal to, let's see, I bring this over here, I get a positive, and this is going to be negative, right? So C4 is equal to A over B minus the natural log of P0, right? I brought the C4 over to here and bring this over to there. So I get A over B minus the natural log. So that's my C4. So my final answer let's see. My final answer is, I forgot what C4 is. Yeah. So my final answer is P. Well, let me write P is equal to E to A over B minus C4. So the final answer is P is equal to E over the AB, and then C4 is AB. Let's see, there's a minus sign here. C4 is AB, right? Natural log minus the natural log of P0 times E to the minus BT, right? Did I do that right? Right, this is C4. So C4 is equal to this. Oh, did I forget? Yeah, C4 is equal to this, right? Okay, I'm plugging it back into this equation. Okay, this is, I need to put an E to the minus BT here, right? Okay, right? So, so this is the equation, this is the solution to the differential equation in terms of the constant C, right? And then I find the constant C by using the initial condition of P0 is equal, that at time T equals 0, I get P0, right? So, so when this is 0, this is just 1, right? This is 1, right? And, okay, so then I solve it for C4, and this is what I get for C4. And then I put the C4 in here. And so let me write out my final answer a little bit neater. So my final answer is E to the AB minus AB minus the natural log of P0 E to the minus BT. Let's see, is that what the key, is that the answer to the answer key? Oh, here it is. Here it is. Okay. Okay, so this is what the answer, the book answer is. Okay. Okay, so it's correct. They just, the only difference, I got the E to the minus BT here. and they got it in front. I got it in the back, they got it in the front. Okay, so that's the solution. So this is the explicit solution as a function of time for this differential equation. So this was kind of a lot of little bit of algebra. I think maybe a little trick is knowing that you know what U substitution to use. And then it's using property of logarithms and exponentials. But I want to do a problem like this because I kept on changing the constant, right? I kept on changing the constant. Okay, I think that's it for today. I think there's a couple of people that want to take the exam today. I'm going to be, I'm going to be doing more practice for the exam tomorrow. But the two people, I think it's two people that want to take the exam. Don't forget it. For you, it's due back on Thursday. All right. And you're going to submit it through Blackboard. So what you're going to do is you're going to go on Blackboard. Let's see.
I would also like to take the exam today. I have work tomorrow evening, so.
Send me an email after class and I'll send me an email right after class today and I'll forward you the exam. All right. You're going to be missing out on some more practice, but okay. All right. But you're going to submit. Let's see. Go to student mode. Why is it okay? Does everybody see my screen?
Yes.
Okay. So okay. So you're going to go here. If you take a look, you're going to submit your exam through here. Now make sure everything's readable. Make sure all the images are facing the right way. Okay. Please make sure it's readable. Sometimes I get students where I always get one or two students in the class where I can't read it or the images are upside down and I'm just going to submit it back to you. And depending upon how bad it is, I could take off points. So make sure that it's readable and that you don't have your images facing sideways and upside down and backwards. Okay, so you're just going to submit it through here. You're just going to browse your computer and you're going to locate the file just like you attach a file to an email and you'll upload it. And if you want to put any comments in, you can. All right. Okay. So once again, I'm going to go over some more stuff tomorrow for the exam. And so the people that want to take the exam today, for you, it's due back tomorrow. Okay. Tomorrow at midnight. Okay. All right. So that's it for today. So I think it's 3 people now that want to take the exam. But I'm going to give you more hints tomorrow. Okay. That's it for today.
Thank you.
And
Have a good day.
for those of us who want to take it today, you're going to email it to us?
No, you have to send me an email and I'll respond back to the email.
Okay, thank
So
Thank you.
Professor, I have a question.
Okay.
So for the Blackboard upload, you can upload, is there a limit into it or no?
No, there's no limit. I set no limit.
Oh, okay. All right. I just want to make sure. Thank you, Professor. Have a great day.
Okay.
Bye.
Thanks, Professor.
Yes.
Take care.